Section 2.5, Polynomial and Rational Inequalities. Yeah, we will learn solving quadratic inequalities, solving quadratic inequalities with higher degree, and solving rational inequalities. Solving quadratic inequalities. Now, a standard quadratic inequality is of the form ax squared plus bx plus c bigger than 0 or less than 0 or bigger than or equal to or less than or equal to. Now, the procedure is this. First, you have to write the inequality in standard form, so it means bigger than or less than or equal to, we have to have a 0. The important thing is we have to have a 0. If you have x squared plus 1 less than x, you send it to this side and you get minus x less than 0. So first we have to do this. Now then you will find the roots of this polynomial, and if there is no real root, the interval used to be used in step 3 is the all real numbers, the real line, negative infinity to infinity. Okay, after roots of the polynomial, you draw the number line with the roots labeled, and pick a test point for each interval determined by zeros, and determine the sign of the polynomial in each interval, and then identify which interval make the inequality true. Okay, we will go over the steps in the examples. You will learn this in detail. Now, solve the inequality x squared minus x bigger than 30. Now let's go step by step. 1. Write the inequality in standard form. So you send 30 to this side, so it makes x squared minus x minus 30 bigger than 0. One important thing here is you have to pay attention to here, because you will use it at the end of the solution process. So the important thing here is this bigger than 0. So bigger than 0 wanted. So positive intervals wanted. It's important. And then you set it equal to 0. This polynomial, you make it equal to 0 and solve it. Like, we can use factoring to get the solution, and the roots are x equal to minus 5 and x equal to 6. Then the next thing is you will draw the number line and put minus 5 and 6, and always put infinity here and then negative infinity. Then the next thing you have to do is to pick a point from this interval. Okay, let's pick negative 7. It's here, and then you will put negative 7 in the equation. So it's like not in the equation, but in the polynomial. So you have x squared minus x minus 30, and then you put minus 7 here, minus 7 squared, minus 7, minus 30. So this makes 26. When you calculate this, 49 plus 7 minus 30 makes 26. Now 26 is bigger than 0. So then you say x squared minus x minus 30 is positive on this interval. So you can put here plus. So you have plus, then you write here plus. Then you will do the same thing for each of them. So you come to here, just for this one, choose. We choose a point. Okay, let's say 0 is a good point here. It's 0 is here. It's between minus 0, and put it in x squared minus x minus 30, 0 squared minus 0 minus 30. As you see, you got negative 30. So you say it's negative. So you write here minus. And then you choose x okay, take a number from here. I would say 100. Okay, 10 plus 10. So maybe it's 10. Choose any point. So put it in the polynomial. Substitute this in the polynomial for x. So this is equal to 100 minus 40. It makes 60. So 60 bigger than 0. So it's positive, you see. So you say it's positive. Then you make this plus minus plus. Now, okay, now these are written in here. In these steps, I did those. For each interval, we choose a point and we put it in the polynomial and see if it is positive or negative on that interval. Then, okay, we have the sign chart. We can call it sign chart. Then in the sign chart, we have this. Now we go back to here, to step 1, and see what is wanted. It says positive intervals wanted. So what does this mean, positive intervals? So we have to find the intervals where it's bigger than the x squared minus x minus 30 bigger than 0. So it means you take plus positive intervals. So it means this. Why I want this plus, okay, because it says this. And then, as you see, the positive intervals are minus infinity to minus 5 and 6 to infinity. You can put here infinity. And this is not excluded, so we take the union. So the solution set is negative infinity to negative 5 union 6 to infinity. Here, one important thing here is this is a strict inequality. So in strict inequality, no brackets. No brackets. If you have strict inequality, there's no equal case, so no, we don't use the brackets. We use curly parentheses here. Let's look at this exercise and let's try to do it. Solve the inequality and express the solution in interval notation. Okay, first step is write it in standard form. So how do you write it in standard form? So it's in standard form now. Okay, you do everything. Okay, if you get 0 in one of the sides, so it means it's in standard form. And okay. Okay, we have to be careful. Okay, we have to pay attention to here. This is also important. What is wanted? Plus or equal to 0. Negative intervals wanted or equal to 0 wanted. Okay. Now the second thing is find the roots, set it equal to 0, and find the roots. You can use substitution method. You can use factoring here. That will give you 2 roots, or okay, sometimes be roots or zeros. Negative 2 and sorry, it's a negative 9 and 2. Then the third step is put them in the real line. Okay, where is negative 9? It's here. And 2 is here, so I put here negative infinity and plus infinity. And then choose a point here. Choose x equal to, let's say, minus 10. Okay, if you choose minus 10 and put it in the, substitute this one in x squared plus 7x minus 18. So you got negative 10 squared plus 7 times negative 10 minus 18. So it will be 100 minus 70 minus 18, so it will be 12. So as you see, 12 is positive. So you say now, go back and you say it's positive interval now. So the polynomial is positive for the x values on that interval. And we will repeat the same thing for the other intervals. Okay, choose x equal to 0 and plug it in x squared plus 7 minus 18. So this is, you're taking this one. Now we're not dealing with this anymore. So 0 squared plus 7 times 0 minus 18, so it makes negative 18. But as you see, we have negative, so you come here and you say this is negative. Then the last one, choose a point. Okay, choose x to be like 10. Okay, let's see how it goes, and plug it in. Plug 10 in x squared plus 7x minus 18. So 10 squared plus 7 times 10 minus 18. So it will be 170, 152 maybe. Yeah, so this will be plus, so positive. So you put here plus. Okay, we are done with the sign chart. After we do the sign chart, we determine which intervals we have to take as a solution. So here, the important part here is this one. What is wanted? So this, it says negative or equal to 0 wanted. So negative part is this one. So negative intervals wanted. So definitely it will be this interval, and equal to 0 wanted. So when it says equal to 0 here, equal to 0, then you write the solution in brackets. Then you write the solution set is negative 9 to 2, but in brackets because of equal to 0. Okay, so it's negative 9 makes it 0. So we want negative 9 to be inside the set, and 2 inside the set. It's there included, because 2 is a 0. Of 2 makes the equation 0. So 0 in equality case is wanted. So we put the brackets here. So if you have equal case, so equal case gives you the brackets in polynomial equations. I mean inequalities. Okay, let's look at this problem, this exercise. Okay, we have a quadratic inequality here, and we want to solve it. The first thing we have to do is put it in standard form. Okay, now you send this one to the other side, and you get this one. So what is wanted? So negative or equal to 0 wanted. So negative intervals or equal to 0 wanted. Then step 2 is find the solution of this. Okay, then here you can use factoring, but the quadratic formula will work better here, because it's hard to factor this one. I mean, we cannot factor it with integers. So we use quadratic formula, and we get 2 roots. So the roots or zeros are, one of them is 1 plus square root 2, the other is 1 minus square root 2. So we have to put them now on the real line. Let's put them on the real line. Okay, the zeros or roots, we mean the roots here, are 1 plus square root 2, it's about 2.41, and it's about minus, this one is minus or negative 0.41. This is important to find the location of this point in the real line. So you make the real line and you put these points. It's where is 0? It's here, 0. And this is about like negative 0.41, and this is about like 2.41. It's about, yeah. So 0 is between them. At least we know it, because these values are important, because when choosing the numbers here, you have to make sure that you don't choose 2. So it should be more than 2.41. So you can choose 3, 4, 5 here, and here you can choose -1, -2, because the location is important here. The location of that point is important, because 1 point from here, it's not easy to understand the location. Anyway, now let's choose the points here. We choose a point here. Let's take x, or choose x to be -1, and plug it in here. So plug it in x squared minus 2x minus 1. And when you have it, so you got -1 squared, 2 times -1, -1. So this makes 1 plus 2 minus 1. So it's 2. 2 is positive, so you can say this is positive now, this interval positive. Then we take another number here, 0. Okay, take x to be 0, and put it in the polynomial here. So we have negative value, so this means on this interval the polynomial is negative. Then we do the same thing for the last one. Okay, I will take here, so it has to be bigger than 2.41. So I'm taking, let's say 10. So let's see, take x equal to 10 and put it inside this, the polynomial. That's will 10 squared, 2 times 10. This will be like 100. Okay, you can calculate this, but it's obvious that it's 100 minus 20 minus 1. It's definitely positive. So it's positive. It's bigger than 0. So this thing is definitely positive. And when you write, okay, so you have to write it here as positive. Now we did the sign chart. Okay, let's see what is done in the slide. Okay, so one other thing, okay, you can do it this way, like for each interval, take a test point and put it in, in the polynomial, and it gives you 2. So this, you say it's plus, this is minus, and for another test point, it takes plus. So it will be plus, minus, it will be plus. You can do it this way also. Then we have to write the solution set. What is wanted? It says negative or 0 equal to 0 wanted. So where is negative? It's here. Definitely it's here. So it will be, okay, the next thing is we have to, okay, this is negative, it's here. So step 4, the solution set is this part, negative part, negative, and equal to 0 wanted. So we have to take these, okay, they're included. These numbers, they are in the set, so we put the brackets here. So this is the solution set. Okay, let's look at here. It says, there's a reminder here, there's a remark, not all quadratic inequalities have a solution. For example, look at this one. X squared, can it be less than 0 in real numbers? No, it doesn't have a solution in real numbers. So we can see it using our usual procedure. What's the procedure? First, what is wanted? Negative wanted. Solve x squared equal to 0. We got only one x value, the root 0. And then make the sign chart. Okay, we'll draw the line, so put 0 here. 0 is the root. And then pick -1 here. Pick -1 and put it in x squared. So it's -1 squared is equal to 1. So this makes positive. You see it's positive, so we have to say this part is positive. And take another number here. Good. Okay, take or pick 1 here. I'm saying take 1 because it's 0. It has to be bigger than 1. So it's 0. Okay, it has to be bigger than 0. I have to take a number on the right hand side of 0. So take 1 and put it here, put in here x squared or x squared. So you got again another positive value. So we got here positives here, as you see. Then this one here, it will be plus and plus. But it is wanted negative. It is wanted negative. There is no negative interval. That's one thing. No negative interval here. Interval. And the other thing is the root here 0 is not included in the solution. It's not included. Why? Because there is no equal sign here. If we have equal sign, then what makes it equal? X equal to 0 makes it equal. So we will take it, but it's not included here because we don't want it to be 0. So the solution set is empty. So we find the intervals. We find the intervals at which negative. We find the intervals at which is okay. We find the negative intervals, and there is no such interval. So they are all positive. So the solution is empty. And also the one important thing is we don't have the equality sign here. If it was saying the equal here, would take x equal to 0 is the only solution. Okay, let's solve another equation. Okay, I will go a little fast. Send this one to this side, make it in standard form, and now we want the positive or equal to 0 wanted. So we have this or equal to 0 case. See? So you have to pay attention to this at the end. Now we want to find the solution, okay, of this, the roots or zeros. Then you find this. Surprising. So we have I here, and these are not, okay, the roots are, here you got, roots are not real numbers. Not real. So if they are not real, you cannot put them here. You cannot do anything. So in this case, what will you do? In this case, the roots are complex numbers, so there is no real solution for this one. There is no real root. So next, step 3. In this case, if there is no real root, the polynomial is all positive or negative on the real line. So you take any point, it might be 0 or whatever, you put it in the polynomial. So take 0, put it in the polynomial at 1 when it's positive. So what does this mean? Okay, shall we draw the line? Yeah, the real line, yes. But this time, no real root here, no roots. So you don't put anything here. It doesn't make intervals. So what you do here is you put minus infinity, infinity, and you say this is positive. So no roots, positive everywhere. Everywhere positive because there is no root, no real root. So in this case, what is wanted? Positive or equal to 0 wanted. So we take positive intervals, they're all, so it's always positive for all real numbers as we see here. The solution is negative infinity to infinity. So the solution set is minus infinity to infinity, or you can say all real numbers. We can say or. Okay, in this example, what you see here is if no real root, you have all plus or all minus here. Okay, if there is no real root, this is important. So how do you decide plus minus? You choose a point, test point, you put in the polynomial and you say it's positive, so you say it's all positive. Okay, let's look at this problem. Let's make it into standard form, and here we check this is positive intervals wanted. That's nice. Okay. Then we take the roots. You solve this one here. This x squared minus 4x plus 4. You would find the roots of this polynomial. This one. Then when you try to do it, like you can use factoring, and then the only root turns out to be 2. What's next? The next thing is you have to draw the real line, put 2 here, and check, Okay, test the sign of the polynomial on these 2 intervals. So we can use 1 and 3. So here you can do this. First draw it, put 2 here, and take 1 here, and take 3 here. So you put them here. Put them here. So it's 1 squared minus 4 times 1 plus 4. So this will make 1 equal to 1. This is plus. So you write here plus. Now take 3, and put it here. 3 squared minus 4 times 3 plus 4. So this will make 9 minus, okay, this will be plus 1. You see it's plus, so you put here again plus. Okay, now positive intervals wanted, but there is no equal. There is no equal to case, no equal case here. So if this is the case, no equal to case, then we don't take this 2. 2 not accepted. Because when you put 2 squared minus, because 2 makes x squared minus 4x plus 4 equal to 0. So this equal to case is not wanted because we don't want equal to 0. We just find the positive intervals. So we take all positives, but not 0. the value. Okay. So we find the intervals strictly bigger than 0 plus. These are these two intervals, negative infinity to 2, 2 to infinity, 2 not accepted, because no equal to. So the solution set will be, okay, they are disjoint, you cannot put them together. 2 is not included, so this is the solution set. Okay, solving higher degree polynomial inequalities. It's exactly the same procedure as the quadratic inequalities. The procedure for solving higher polynomial inequalities are exactly the same as quadratic inequalities. The first thing is you have to write this in standard form. So it makes bigger than 0 here. So you say the positive or equal to 0 wanted, and then you find the roots and the intervals. Okay, how do you find the roots of this? The roots of this. So you write x cubed minus 4x squared minus 12x equal to 0 and solve it. You can use factoring maybe. Do factoring also here. Okay, you can do the factoring and you will get these factors, and this is equal to, it gives you the roots. Okay, the roots or zeros here. Same. 0, negative 2, 6. So zeros, when we say zeros, we mean the values making this 0. And then the intervals checked. So you can put, okay, you can divide draw the line and divide it into the intervals, like negative 2 is here, and 0 here, and 6 here, and then check. Yeah, check this one and check all of them. Check. You're checking like it. Check if plus or minus. You know the procedure. Okay, put them, and then for each interval, like pick a test point. We can visualize it this way. Pick from here. You can pick negative 3 and put it in the polynomial. So you got negative 27. It means negative. So you put here negative sign. So to pick minus 1 from here, minus 1, then put it in the polynomial. It's positive. And okay, you can take here. 1 is somewhere here, right? 1. So you take this point, put it in the polynomial, and you got negative 15. So you say it's negative. So we have, so far we have plus, minus here. It's plus, there's this minus here. And for this one, you can pick 7. Pick 7 and then put it in the polynomial. You got 63, which is positive. You write here plus. Okay. Now this makes the sign chart of the polynomial. Okay, the sign chart of the polynomial. Here we have this one. Now it will be minus here and plus here and minus here and plus here. So it's coming from this part here. And then what is wanted? Do you remember? Okay, so we wanted positive or equal to 0. So positives are those. And there's an equal sign, so we will put them like these will be included. They will be included. So this is infinity and this is minus infinity. And we can write the solution as minus 2 to 0. It will be minus 2 to 0, union 6 to infinity. Okay, the answer is negative 2 to 0 and 6 to infinity. So this is the answer. Okay, let's look at this this try and check exercise. Look at here, this is x cubed minus 6x squared minus 5, step 1, standard form. You have to write it in standard form. So this is how you do it. Send this one here and you got 0. Standard form. So, and also pay attention here, what is wanted? Positive wanted. Intervals wanted. This is important. Now the second thing is solve. X squared minus 6x squared plus 5x equal to 0. Okay, this is x cubed, sorry, this is x cubed. You can factor it. This is the, the solution method is generally factoring. You can use quadratic here as well, but I think you can, we can factor this one as minus 5 and minus 1. So this gives you x equal to 0, 1, and 5. These are the roots. So we have, now the solutions are, the roots are zeros. I don't say the roots. Zeros are x equal to 0, 1, and 5. Now the third thing is I will do the sign chart. Okay, put 0, put 1, and put 5 here. It's plus infinity and minus infinity. And take values and put plug here. Take x equal to minus okay, minus 1 should be better because it's easy. Okay, put it in here. Minus 1, minus 6, minus 5. So as you see, this is minus 12. It gives you minus sign. So as you know, as you see, it's minus, so I will take this one to be minus here. And now I will change the interval and then use another number. Okay, take for this part, take 1 over 2. The best option is, it seems, 1 over 2. Here, you can use the factoring of this. The factoring will help us. You can write it this way. You put 1 over 2, over 2 minus 1, 1 over 2 minus 5. Since we are interested in, the sign, it's positive. This is negative, and then this is negative, and like when you multiply them, you get plus. You can say here it's plus. We are not interested in the numbers. We are interested in the sign of the polynomial in that interval. So use the same logic and try to do them here. Take 4, for example, and put it here, x times, okay, x cubed minus 6x squared plus 5x. Again, you can use the factoring here. This is a good way of finding the, put 4 here. Like instead of doing, putting, calculating this, you can say 4 times 4 minus 1, 4 minus 5. So it will be plus times minus. So it gives you minus. So this will be minus. So here we got minus. You put here minus. And we take another one here. Let's say take 10. Okay, put 10 here. And it will be 10 minus 1, and 10 minus 5. So it will be some positive number. You see it's positive, positive, positive. So it will be positive. You take here positive. So we are done with this sign chart. Then after finding the sign chart, we have to see what is wanted. Okay, we have to check what is wanted. Okay, what is wanted from us? So positive. Okay, guys, I'm really sorry. I'm a little tired, and I'm doing this video is always tired, always at the evening. So it has to be negative wanted, okay, negative. So this wanted and this wanted. So you say negative. The solution set is. Okay, we take minus infinity to 0. Okay, 0. Okay, 0. This or this? Which one? No equal sign. No equal sign. So no equal sign. You take only curly parentheses, no bracket. And then union, negative. Again, this one, negative. So again, 1 not included and 5 not included because of no equal sign. So this is how we solve this equation. The solution set should be this. Okay, these are the steps we follow all the time. Now, let's see how to solve radical inequalities. Rational inequalities. So in rational inequalities, we are talking about the inequalities involving fractions. So for example, you have a fraction, you have another number. Okay, we will learn how to solve such inequality. The main important thing is to put them in this form. We can call it standard form. Standard form. Always we want to see 0 on the right side or on the left side. The procedure is write the inequality in this form. We want zeros here. This is important. And find the zeros of the denominator. So root of the denominator and the numerator. We have this one. We find px equal to 0, qx equal to 0. Solve them. Solve them. Okay, then the next thing is make a chart, sign chart. Put the zeros here, and then put minus plus. Check them. You know how to check them. You will take a number and put it here, and then after this, perform the sign analysis. And okay, you have to be careful what is wanted here. That's one important thing. Determine the intervals on which the expression takes the desired signs. Wanted signs. Check if the inequality is satisfied at zeros, and include those in the intervals. And write the interval or the union of these intervals as a solution set of the inequality. Okay, let's look at here. Solve the inequality. This is in standard form first. Okay, just write the inequality in standard form. It's already standard. So this is already in standard form. Okay. Now check what is wanted. negative or equal to wanted, negative interval is wanted, or equal to wanted, equal to 0 wanted, because there's an equal sign here. And find the zeros of the numerator and denominator. Numerator cost, denominator makam. Do you solve them? Yeah, how do you solve them? How do you find the roots? You set them equal to 0, 0, 0, and then you got these two roots. Then the next thing is you will put them in here. And okay, you can put negative infinity, positive infinity. You make the real line, and you put them in the real line. You place them in the real line, and then the next thing you can guess, we will do some tests. So perform the sign analysis. How? Just pick a value. Like take here, for example, is -1 here? Yes, it's less than, no, this less than -1 or 2, so it's okay. -1 is here. Yeah, take -1, take -1, and put it here. What do you get? It's 5. So 5 means bigger than 0. 5 need positive. So you say it's positive, so you can put here positive for this interval. Now do the same thing for the other one. Okay, you can pick, okay, a number, pick a number between -1 over 2 and 2 over 3. A good option is 0. 0 is a good one. Take x equal to 0. So take x equal to 0 and plug it here. Okay, and you have to take the standard form. Okay, take the rational in standard form, this rational expression. Sometimes they're not the same. You see, in this question it's okay, they're same, but not in all questions. You know, put 0, you got 3 minus 0 times 0 plus 1, so it makes -2 over 1. So this is, you see, negative. So then you put here negative sign. So this is negative. And we have one more thing to do. We have to do the same thing for the last interval. So for this one, we have to choose a number. Okay, here, how it is choose, like you can pick 1 here. It's about 1 is bigger than 2 or 3. It's here. Put it inside, in here. And you got 1 over 3. 1 over 3 is positive. So you say it's positive, you put it here. So this is telling each, testing steps, picking some points from each interval. So the only thing I'm doing is I'm trying to visualize the things, because reading this you might not understand, but from here you can understand. Okay, the next thing we have to do is, we put this pluses and minuses here. Okay, or plus, minus, plus. And what is wanted? Negative interval is wanted, or equal to 0 is wanted as well. So the next thing is we have to pick the negative interval. So this will pick it. So definitely it will be from -1 over 2 to 2 over 3. But the problem here is, okay, we have to be careful. The question here is this or this? Which one? Curly bracket, or curly parentheses, or this one? And here again, this or this? This is the important things here, so we have to be careful. Again, like I can write it here. I can write it like this. but which one or something else? How to decide? Okay, it always comes to here again. Now, you'll write the solution. The solution is this, y. Okay, now, -1/2. So this one says, the equal sign says, use brackets. Okay, we use bracket, but use this for the root of the denominator. For this one, you always use this, because this is the 0 of the denominator. We don't accept it. We do not include -1/2. This 3/2. Okay, but this not accepted, because this makes the denominator 0. So this is excluded. So this is okay, but this one is not. Okay, -1/2 is not included in the solution, but 2/3 is fine. But here, why? Because -1/2 makes a problem here. Makes a problem in the numerator, in the denominator. So we do not take, okay, as a rule, like we can say, never include the root of the denominator in the interval, in the solution interval. Never include. So this is always with -1/2. Okay, not this one. We do not include it. Okay, let's try to solve this one. Now, this is not in standard form. You see that? Not in standard form. So how do you make the standard form? So the first thing you have to do is write it in standard form. So how can you do that? So the best way is to send this one. Okay, that's the one other thing here is, like, when solving the inequality, we never do this. Okay, don't do it ever. Okay, don't do this first. This is first warning. Do not do this. Okay, like A, B, like this, you know, don't do it. In the inequality when solving for x, don't do it. Do not cross multiply when solving the inequalities. This, you will get this one, and this is wrong. Okay, first we have to write it in standard in standard form. It means this. So the first thing you have to do is like send 4 to the other side. Okay, this writing is not good because we want it to be like px over qx. So you have to write it as a fraction. So how can you write it as a fraction? Okay, let's do it. Like, how do you add two fractions? Like subtract two fractions. You write here. You multiply with 2x plus 1, this one, and this one. You will get this. And then now we have the same things, and we can combine these two. So it will be okay. Always put this in parentheses because there's minus. And open the parentheses and do this job, and at the end you got this one. Okay, you can check. Like, you can stop the video and check the steps here. And then at the end we got the standard form. Okay, now we follow the steps. What's next? The next thing is, okay, before doing the next step, so we have to pay attention to this. So what is wanted, negative or equal to 0 wanted? That's good. And identify the zeros of the numerator and the denominator. So it means set them equal to 0. Set this equal to 0. This is maqam. This is cost. This is maqam. And 2x plus 1 equal to 0. You'll find the roots. What's the next thing? You have to make an analysis chart. So you put these numbers, the roots, on the real line, and then test. Pick test points. Pick -2. Put it inside the root, the px over qx, which is okay, I don't remember it, but it has to be -5x, -6, and 2x plus 1. You put -2 here for x. And then check, this is negative. You say we have negative here. So this has to be negative. Then pick another number. Pick this number here. What can you pick here? I think between them, it's hard to find a number. Okay. What can we do? Okay. How about taking something like, okay, is -1 bigger than this and less than this? Yeah, okay, it's better we pick x equal to -1. And then plug x -1 in here, -5x -6 over 2x plus 1. Plug it here, and then you got -5, -1, -6, and 2 times -1 plus 1. Okay, indeed, this is done in here. It's already done. So we get a positive number, so we say it's positive. 1, it's positive, so you say, let's put the positive here. And then for this one, we pick another number. Okay, we can pick 0 here, so because 0 is somewhere here. We can pick 0 and plug it in the rational expression. This is how we do it. I mean, then we have negative, so you say here it has to be negative. Then we have this sign chart. We have this sign chart. Then what to write here? What was wanted? We choose these negative intervals here. You know, we have to go back and see in step 1 what is wanted, negative wanted. And there's a strict inequality. Is it? Okay. The endpoint, okay, there was this, this was wanted, okay, it's wanted. Negative wanted, negative, or equal to 0 wanted. Wanted. So, for this intervals, we are fine. It's negative. What about the equal to 0? So what makes them equal to 0, or what makes the expression equal to 0? So you check the endpoints. So the endpoint means like -1 over 2 and -5 over 6. Okay, -1 over 2 is always out of question. Why? Because it makes the denominator 0. It's automatically not included. But -5 over 6, so when you put -5 over 6 here, it makes 0. 0. This is wanted. So you write the equation this way then. We want negative or equal to 0. Okay, this doesn't make it 0. This is not included because it makes it undefined. So when you put it here, it will make it undefined. So this is the solution set for the equation. So you have to be careful about the endpoints.